All right, boys and girls, we're going to talk about some factor and remainder theorem today. We got to first review what synthetic division is. So synthetic division takes the coefficients and the opposite number here. So in this case, it's 3. And then we bring down the first coefficient, we multiply, we get 3. Negative 2 plus 3 makes 1. 1 times 3 gives me negative 1. Gives me negative 3, and that means my remainder is 2. Now there's a remainder theorem. And that remainder theorem says that if we have a polynomial like this, and it's being divided by this, if we take that c, so take 3, plug it in, that's going to give us 2. So it's just kind of a quick shortcut to getting the remainder. So that means I'm going to take 3, I cube it, minus 2 times 3 squared, minus 4 times 3 plus 5. So when I do my PEMDAS, and I'll be sure you do it correctly, that's going to give me 27 minus 18 minus 12 plus 5. And yeah, sure enough, that's 2. Now, the reason why we're doing that, you know what, I'm going to hold off on that. We'll get to that here in a second with the factor theorem. Let's just practice getting the remainder a couple more times. So I've got a couple more examples here. 79, or x is 79, 3x 24th plus 5 divided by x minus 1. So that means we're just putting 1 in. So 1 to the 79th plus 3 times 1 to the 24th plus 5. Well, 1 to anything is still 1, except for 0, I guess. So you get 1 plus 3 plus 5. So my remainder is 9. Now you can find the remainder with the remainder theorem, or you can still do division. You do synthetic division or long division. Either way, we're going to be using negative 2. So negative 2 goes here, or negative 2 goes here. I like synthetic division. It's a little quicker. I don't have to put all this in my calculator. It's real quick. You know, this gives me negative 6. Bring that down. This gives me 12. That's 4. That's negative 8. This is 3. That's negative 6. And my remainder is negative 1. That was pretty quick. I'm kind of good at it. But anyway, so the remainder is negative 1. Okay, now the whole point of doing all this is for the factor theorem. And we can do the factor theorem because of the remainder theorem. So the factor theorem says that a remainder of 0 means you have a factor. And so that's why we've been doing all this factoring. That's why I've been doing, just hitting all that so hard, is because we're eventually going to get there. This has all kind of been building up. So we're going to show that x minus 3 is a factor of this whole thing. So if you take 3, put it into the remainder theorem, and we get 0, that means that x minus 3 is a factor. Or if we do our division here, there we go, and our remainder is 0, that means this is a factor. So yes, it is a factor. Now showing that is either with synthetic division or with the remainder theorem. And so that equaling 0, that would be showing that x minus 3 is a factor. If you don't do that, you haven't proven anything. You got a 50-50 shot, yes or no. The last thing on here is finding a polynomial with given degrees and the given zeros. Now, let's review what a quadratic is. If I want to figure out where exactly this crosses the x-axis, I can factor this. So it's x and then x minus 5, x minus 2. So that means I get x is 5 and x is 2. Okay, so same idea here. If it tells me my zeros are 2, 1, negative 5, negative 6, I can just do x minus 2, x minus 1, x plus 5, and x plus 6. Now I haven't talked about what this is. The n equals 4 is the degree. So a couple days ago we talked about like x to the 5 plus 7x to the 4th plus 2x to the 3rd, blah, blah, blah. The degree is the highest exponent, 5. So I need a degree of 4 on this one. So is my degree 4? Well, if I FOILed this out, which I'm not going to do, but if I just did the first term, x times x times x times x, I get x to the 4th, which is what I wanted. Example 2, I got 2 zeros, so x minus 2, by the way, y equals, my bad, and x minus 6. But I'm supposed to have 3. So if I put a 2 on one of these, I would get x times x, which is x to the 3rd. So I got it. And then lastly, y equals, I got a 0 of x, or sorry, x 0 of 7, so it's x minus 7, degree of 4, so I can just put a 4 right there. Okay? Good luck. See you next time. Bye-bye.